Hubble telescope observes the farthest star in the universe. The Hubble Space Telescope was able to observe the farthest star ever seen, a light source that appeared barely 1 billion years after the Big Bang. This discovery, one of the most astonishing in recent years, was made public by NASA on March 30, 2022. With the help of one of the most potent telescopes available and a small bit of luck, this incredible discovery was made. According to observations, the Hubble-discovered star, known as Rindle, began to generate light in the first billion years of the cosmos. When compared to Hubble's previous distance record from 2018, when it discovered a star with an estimated age of 4 billion years after the Big Bang, this is a considerable increase in distance. The Hubble telescope was assisted by the cosmos when it observed through space that had been distorted by the massive galaxy cluster WHL 013708, which produced an effect known as gravitational lensing everywhere around it. As a result, the star Earendel, which was oriented very closely to a wave in the fabric of space caused by the mass of the cluster, was visible. Hubble was able to identify this star's increased luminosity. Only the star's distance and brightness are known at this time, but it is anticipated that as soon as it starts operating, NASA's James Webb Telescope will continue to observe to determine the star's temperature and makeup. However, we are all very interested in learning more about this star and its environment because that would show us the conditions that the environment of the early universe had. For the time being, astronomers are cautious in the possibility that Earendel is one of the stars of the first generation of the universe is not contemplated. How far away was the star found by Hubble? With a redshift of 6.2, the recently discovered star is so far away that it took 12.9 billion years for its light to reach Earth. As a result, it seems to us as though the universe was only 7% as old at that time. It has never been conceivable to view a single object as small as a star at such a long distance. The smallest objects ever spotted at such a big distance are star clusters embedded within the first galaxies. Lead author of the paper describing the discovery, astronomer Brian Welch of Johns Hopkins University in Baltimore, mentions that data from Hubble's RELIX, Reionization Lensing Cluster Survey, program, directed by co-author Dan Coe at the Space Telescope Science Institute, were used to make the discovery, STSCI, also in Baltimore. Redshift. When an astronomical object, such as a star or galaxy, is far away, its visible light spectrum moves toward the redder light stripes. This phenomenon is known as redshift in astronomy. What causes this to occur? The redshift is a result of the universe expanding and the galaxies moving away from one another at a faster rate. As a result, the light waves that travel through the universe are stretching and losing energy, which causes the colors of the galaxies to move toward weaker visible light frequencies, i.e., the red ones. Because light has to travel a greater distance and for a longer period of time, the redshift of a galaxy or star increases with distance. The Hubble-discovered star is the farthest solitary object ever seen. It is situated at a distance of about 13,000 million light years, but due to its brightness, we were unable to get an image of it. If a galaxy at this distance is often difficult to detect because the light from millions of stars is concentrated into a single point, then how did we manage to see a single star that was so far from our galaxy? We were able to see this star as an individual entity enhanced by gravitational lensing, a natural magnifying glass, since the star's light traveled through a gravitational lens created by a massive galactic cumulus that magnified its light more than 1,000 times. But what are gravitational lensing? In astronomy, a gravitational lens is created when light from far-off, brilliant objects, like quasars, curved around a large object, like a galaxy, that is situated between the transmitting object and the receiver. General relativity, as proposed by Einstein, foresaw gravitational lensing. During a solar eclipse in 1919, it was feasible to test the validity of the hypothesis. Astronomer Arthur Eddington saw how the trajectory of light from far-off stars twisted as it approached the sun, appearing to shift the stars' positions. A gravitational lens is a deformation of spacetime brought on by the presence of huge objects, and the more of these items there are, the more gravitational lensing occurs. The light coming from extremely far-off objects can be magnified by hundreds or even thousands of times thanks to gravitational lensing. The star Earendel was discovered in this manner. Moreover, gravitational lensing can be employed in the exact opposite manner. The mass distribution of the item acting as a lens can be inferred from the distortion of the background sources. This has the advantage of being able to follow the dark matter of a galactic cumulus and is particularly helpful in the case of galaxy clusters. We can't choose where gravitational lenses will form. Instead, we only look for them and hope that something is just behind them so that we can observe it with our powerful telescopes. This is unfortunate because gravitational lensing is not something we can control. Observation by chance. The discovery of the star Earendel, despite what it may appear to be, was purely accidental. The primary goal of the Hubble telescope was to study the galaxy cluster WHL 013708, but because of its massive size, the galaxy cluster significantly warped space, acting as a powerful natural magnifying glass that greatly distorts and amplifies the light of objects behind it. The star Earendel appears in front of the cumulus directly or very close to a wave in space because of this lucky alignment with the crescent galaxy cluster. The maximum magnification and brightness are offered by this ripple, which is referred to as caustic in the field of optics. The star Earendel emerges from the overall brilliance of its parent galaxy as a result of this caustic. Its brilliance is multiplied by 1,000 or more. The James Webb will complete the project. Even though most big stars have at least one smaller companion star, astronomers who have analyzed the discoveries so far are unable to say for certain whether Earendel is a binary star. The initial investigations indicate that Earendel occurred so long ago that it might not have contained all the same raw materials as the stars in our immediate vicinity today. As a result, Earendel will serve as a window into a time when understanding of the early cosmos was at its height. With the technology it currently has, the Hubble telescope is unable to analyze the star in mid- or far-infrared frequencies. For that, we must wait until the James Webb telescope is operational. The Hubble telescope has observed everything that its lenses allow it to observe, but it is no longer able to do more. Earendel should be visible in the upcoming years, according to astronomers. Because of this, we will have enough time to view it with NASA's James Webb Space Telescope. This is because Earendel's light expands to longer infrared wavelengths due to the expansion of the universe, and we require the James Webb's exceptional sensitivity to infrared light to learn more about it. The brightness and temperature of the star should be measured by the James Webb Space Telescope. This information will narrow down the kind and stage of the star's life cycle. Also, it is anticipated to learn what resources the Sunrise Arc galaxy, which houses the star Earendel, possesses. If heavier metals that originate in subsequent star generations are present in the Sunrise Arc galaxy. According to this, Earendel is a rare, huge, metal-poor star that belongs to the second or third generation of stars in the cosmos. Astronomers are very interested in the composition of Earendel because it formed before the universe was full of the heavy elements created by successive generations of huge stars. It would be the first proof of the fabled population 3 stars, which according to the majority of recognized cosmological theories would be the first stars produced after the Big Bang, if subsequent research revealed that Earendel is only made up of primordial hydrogen and helium. Even though the likelihood is remote, experts agree that it's an appealing notion nonetheless because it would support one of the most significant theories in contemporary cosmology. For the time being, the Hubble telescope has completed its task. It is now up to the James Webb telescope to provide us with the knowledge we need to solve more mysteries regarding that star and the early cosmos it was in. A new era of discovery. The discovery of the star Earendel offers up a world of opportunities, and for the time being all that is needed is for the James Webb telescope to start operating. With this telescope, according to the astronomers who made the discovery, we may be able to shatter even more distance records. The oldest galaxy in the cosmos, the first stars in the universe, and the first star clusters are among records that the James Webb Telescope is predicted to shatter. The Sunrise Arc Galaxy, where the star Earendel is located, does not appear to be among the first galaxies to form in the universe, but the James Webb Telescope has not yet been able to rule this out. We may actually be in the vicinity of one of the very first galaxies in the universe and are unaware of it. We could be in the midst of one of the most significant discoveries in history if Sunrise Arc turns out to be one of the first galaxies in the known universe. This would indicate that we are watching the cosmos at the exact moment it was just beginning to develop, 1 billion years after the Big Bang. Although 1 billion years may seem like a very long time in terms of human existence, in terms of the age of the universe, it only accounts for 7% of the total age. For this reason, observing this kind of object is crucial for astronomy. The further distant we can examine the universe, the further into the past we can look. Only with the might of science and our most cutting-edge equipment are we able to see events that took place billions of years ago. The best tool we currently have for studying the far reaches of the universe is gravitational lensing. However, if we were to use the James Webb Telescope, which will allow us to see farther than Hubble, we might be able to see objects that we were previously unable to see if we pointed its mirrors at areas Hubble has already observed. We might come across distant galaxies or the earliest star clusters that formed soon after the cosmos was created. The possibilities made possible by this discovery are enormous, and those that will emerge in the coming years will be even more astounding. Alright everyone, this video ends here. Thanks for watching and see you with the next video.